Hello guys, welcome to my channel Medicinal Pharma Education. I hope you are doing well, preparing well for your semester exams, and myself Shiva, I am also preparing for my M.Pharm exams. Okay, today's topic is in the interference in atomic absorption spectroscopy. In the previous video, we have discussed about the instrumentation of atomic absorption spectroscopy, and we have discussed about the principle involved in and a little bit how flame is different from atomic absorption. Okay, and the interference in the flame is quite similar to the interference in the atomic absorption spectroscopy. There are little bit changes, that's it. And almost the topic is interference in the flame, and the interference in the atomic absorption spectroscopy is quite similar. Okay, then we'll continue with today's topic. Okay guys, let me start the topic. There are mainly, we have already studied the chemical interference. There are mainly three types in chemical interference: spectral, chemical, and ionization. But in atomic absorption spectroscopy, we have one more interference, that is called as matrix. Okay, we will go through one by one each, and we will start with the spectral interference. Okay, spectral interference are caused by presence of another atomic absorption line or a molecule absorbance band close to the spectral line of the element of interest. We have already discussed in the flame emission about the first type of the spectral. This is the interference caused in the atomic absorption also. The interference caused by the presence of another atom absorption line. See, here if the two atoms like fluorine, Fe, and copper, the spectral wavelength is almost similar, so that it is difficult to identify particular element. That is the spectral interference. Okay, if you want to study more in detail, you can just refer the flame interference, where I have explained how it really influences the result. Okay, next, chemical interference. In chemical interference, if a sample contains a species which forms a thermally stable compound with the analyte that is not completely decomposed by the energy available in the flame, then chemical interference occurs. Here the chemical interference, it is telling that if the sample containing a species which forms thermally stable compound. See, the absorption here, if the absorption does not take place, or if it is forms a stable component and the stable component does not decompose, right, the energy does not absorb the energy. It does not absorb the energy when which is available in the flame. Here, if the compound is stable, if a compound is stable, it is quite stable, it does not absorb the energy and it does not emit the energy. If any sample contains the species which are thermally stable, then it does not absorb the energy from the flame. That's the chemical interference. Then if it does not absorb, we can't find the result, or we can't find the sample what is present in the mixture of sample. Okay, refractory elements such as TiW, zinc, manganese, and Ai may combine with oxygen to form thermally stable compounds, thermally stable oxides. See here, these are the some of the elements which can form a stable compound with oxides. See example, this is not stable. If it combines with titanium oxide, this is a stable compound and it is thermally stable, means it does not absorb the heat from the source. Okay, heat from the burner or the flame. That's what it interferes with the result. This is the chemical interference. Next we'll go through with the matrix interference. Okay, matrix interference, this is only occurs in the atomic absorption spectroscopy. Here matrix interference occurs when the sample is more viscous or has different surface tension that the standard it can result in difference in the sample uptake rate due to change in the nebulizer efficiency. See here, nebulizer or The instrument used, you can see in the previous video we have discussed the instrumentation where we use the nebulizer to uptake the sample and distribute the sample into the flame with uniform rate. See here, it should be like uniform rate. If the uniform rate it is, if the sample is not flowing in uniform rate, then fluctuation occurs which may affect in the result. See, if the sample is more viscous or has different surface tension, what happens, right? If we take honey, the flow rate is different than water. If surface tension or the viscosity are different, or more viscosity and different surface tension, what it causes in uneven flow of the sample to the nebulizer. This affects the nebulization efficiency, which in turn affects the result. See, nebulization is nothing but, the effect of nebulization is nothing but, if you take honey, example, if you take honey and if you take water, the flow property of these both are different. This influences the result. This is called as matrix influences, matrix interference. Okay, this is it is due to the nebulizer. It can't pump the sample into the flame at uniform rate because the viscosity is more or it has different surface tension. This is matrix interference. I hope you have understood cleanly. Ionization interference. Excess energy of the flame can lead to excitation of ground state atom to ionic state by loss of electrons, thereby result in depletion of ground state atoms. See here what it happens, right? The flame excites more, it excites the molecule even more than required. Then there will be no ground state to absorb the radiation from the halogen cathode lamp. See here, depletion of ground state atoms. Here it is due to excess energy of the flame. If the flame energy is higher, then the ground state atom does not exist itself for receiving the cathode, for receiving the halogen cathode lamp. Okay, thereby this is also called as ionization interference. I think so you have I hope you have understood the interference of the atomic absorption interference. Take down the notes. This is the notes: spectral interference, chemical interference, and the last one, matrix interference and ionization interference. These are the four types. By this video we will complete the spectroscopy, and in the next video we will start with the another unit, another another subject. I will go with the drug delivery system. We will cover one unit, and likewise we will start the topics. We will start every first unit, we will complete, we will start, and then we will move through the second unit, all the second units, so that I can divert my stress to the next subject. Because making notes for particular subject is very hard. Writing the notes, preparing myself for the explanation, and delivering and editing all the videos for a particular subject for a quiet period of time. For this many of videos for UV visible spectroscopy, IR spectroscopy, and spectrofluorometry, and this flame and atomic, it caused like 1 week for me to make the notes to explain. So that for my hard work, please subscribe, and I hope you are satisfied with my hard work, and please comment anything so that I can be motivated, and just I will surely reply in just half an hour or 1 hour, because I frequently see my views. So that please guys, please support me, and thank you. I'll be working hard. I will not lose my consistency. Thank you guys. See you later in my next class. I hope you are doing well. Have a great day, and enjoy your life.